Let's see. I'll see if someone can hear me, but hopefully you can. It looks all good there. So I'm gonna just go ahead, and hopefully if someone will cut me off if there's a problem before I get too far down the road. Uh, what I was last working on, well, you can't actually see this, is a little bit unfortunate, but I've got my laptop right here next to me, and I was working on the platform layer. I finally have like a sort of SDL thing that's kind of working for now, and it's a humongous pain to build it correctly, so I'm hoping maybe to not always have it. But for now, I've got the SDL in there, so that's good. Or, it's good for now. So it got a window popping up, frame rate's good, and I'm just sticking with that. So then I started working on the threading stuff that I need in the platform layer, and I was looking at some of the stuff in there, and I decided that there were some things I could do to clean up. You can see I already sort of started working on it. I found that these could all just be generalized to be the same on every platform. So now I have this file, which is like, it's for building the platform layer, but it's the same on all systems. So that's good that I've got that working now. And let's see. How can I... Well, the next thing I need to do is there's this long list of functions that the system provides now. Like the platform layer provides these system functions, and there's a lot of them. And I decided I want to pare it down more because, I don't know, in general, the more functions you have, like, functions are harder to deal with than communication protocols. Like, communicating between layers with functions, it's just harder to deal with. You have to pass more pointers to functions back and forth. You have to, like, if you're gonna, like, figure out what's going on, you have to, like, function calls are events, so you have to, like, mark up your functions to record events, etc. If you communicate with data, you can just save the data, and look at it and see what's going on in there. So I think I prefer to just try to find ways to do all of the communication I'm going to try to optimize for as few functions as possible in the system layer on the Windows side, and try to figure out how many things I can do that fit in this file so that they're the same across all platforms before I move forward, because it just seems like a lot of stuff. I'm going to try to see if I can find a setup where I can see all three of my screens or something. Here we go. PD Daddy asks, what systems are you planning to port to? OS X, I hope. The plan right now is just to port to Linux. I want to I figure if I can port to Windows, if I have the abstraction layer set up strongly enough to handle Windows and Linux, then in the future I can do things like OS X. But right now I'm not doing that port. I'm just making sure that the porting is actually possible, right? By doing one port, and then that's like the prototype version of the port. And then when it's shipped day, or at some point along development, when there's enough pressure, because there's like two people, you and one other person, who want OS X, which just means it's not like it doesn't have as much benefit for me to do it right now. You know what I mean? Like, it doesn't help as many people as possible. There are other things I can do that make a big difference. And yeah, if you want to help me with the port, like if I set up a platform layer, and you just want to write the OS X port so that you can have it right away, I would absolutely take help with ports. That is one thing where I have no interest in becoming an expert. So, absolutely, I would talk to someone about how to help me out with the port once I get the porting barrier figured out correctly. Okay, sure, we'll talk. That's awesome. If you want to help me with the OS X port, I'll get in touch with you as soon as I'm ready to do that, because I would love to have someone else work on that. And the other thing is I'd kind of like to someday just like open all of the stuff that it takes to port 4coder. That way, because I have the DLL loader, right? So if you just use the DLL loader and combine that with the fact that the platform layer, the platform interface is open, then you can write for anyone who wants it on their platform can just write their own platform layer. You could even like write it to be a plugin to other things, right? So someday I want to get this platform interface solid enough that I can open it, and so having someone to collaborate with on that process would be good anyway. Okay, so speaking of getting the platform interface good, there's too many functions. This was the initial problem. I want to find ways to reduce the number of functions, and right now the thing I'm dealing with is the fact that there are a lot of things going on with threads, and I've already decided that this stuff here was abstractable, right? That can work the same on every platform. But if you look, there's also all of these functions: getting a thread ID, getting the current job, posting a job, canceling a job, asking if a job has been completed or not, growing the memory that's available to a thread, acquiring a lock, releasing a lock, and forcing redraw. And I'll explain why that's a threading function in a minute. So basically, there's problems with all of these things, which the easy thing to do is to throw the function in there, but it's like, I think what I need to do is make a data communication protocol instead of doing all of this by function. And the question is just how to properly set that up, because it is multi-threaded, which means, do you care, like, for example, what you could do is say, let's take a look at all the points where we do a get thread ID and see what the point of that is. And I suspect that the main reason of using that is when you're inside of a thread, right? Because it takes a thread context, so you have to already be in a thread that's got a context pointer, and you want to know which ID you are for the purpose of like syncing up who your memories and stuff. And it seems like some of that should just be automatic, right? So maybe we can reduce that way. Let's take a look at where that happens. It's probably, if I'm understanding correctly, going to be in here where all the file-related stuff happens, because that's the only place where I have any parallel jobs in existence right now. So system thread, no sign of get ID, widget ID, sure, interesting. Well, there's another way we could track this down, in the struct down here of system functions, there's got to be a get thread ID somewhere. Get thread states. Thread get ID. Okay, so let's actually look for that. Thread get. Still not showing up in this, which is kind of surprising. So who is actually using get thread ID? Thread get ID? Anyone? Oh, thread get ID isn't even in use. So I don't think I want that function. Actually, I just don't want to support it. It seems like there should be ways to do what needs to be done without ever actually having to ask which ID is this thread, right? I don't want to have the user think about that. Because when you post a job, you just say, I want one of the threads to take it. I just don't want them to think about what ID is this thread running on. That shouldn't be a thing. Or what's the idea of the thread this is running on. In fact, if you're in a situation where you want to make a platform layer that handles jobs but non-parallel, that's possible. You just take the job and execute, and then there's no such thing as a thread ID anyway. So it's like a little more, it's a little more kosher, I think, to just not have that. Yeah, okay, so what about this next one? Job ID. Miblo, it's all you in the ranks of the banhammer slamming, because I don't even know how to do that from HexChat, so. Okay, well, the easy way to do this is probably just to comment this out and see what errors we get. So this is about getting the current job ID, and that is given a current thread, what's the ID of the job. Looks like that is completely unused concept as well, which is nice because that means that it's just something I can reduce for free. Right? So it looks like at some point maybe I added something and found an easier way to do it and cut the functions but didn't actually know that I was cutting them. So that's nice. That just pared down the complexity kind of for free. What else have we got to do? We got to take out this one and the current job ID goes away. Okay, great. Okay, so post job is almost certainly being used. And I'm going to ignore that for now because that's a pretty integral one. I don't see any easy way to just turn that into data protocol without some heavy lifting. So we're going to say that that's one of the things that has to be handled very thoughtfully and with a good amount of work. So about canceling a job, same story. Job is pending. Same story. So that's all got to do with looking into a job queue and see what's going on there. And yes, when I say job queue, I'm talking about like data that specifies things you want to do, not the founder of Apple. D7 Samurai asks, what kind of work is being done multi-threaded? And the answer is, right now the main thing that's multi-threaded is the main thing is that the parsing, right? When it goes to parse a file, if it's taking a long time to parse, like, you remember the 10 megabyte file that I demoed, the parser took about 1 frame's worth of time to complete, which means if you did that, like, it had a noticeable like hang if you like between the time that you open the file and the time that it actually opens. So what I'd have is it opens the file but it's uncolored, and then in the background it's parsing, and after 1 or 2 frames the tokens come in because the parsing job is done. So that's the main reason that was added. So this is like background threads, and 1 second. This no, mic's not muted. Anyway, I had a comment that said maybe the mic was muted, but it is not. Okay. So right now it's background threads that like are supposed to take more than 1 frame to complete, and you don't sit and wait for them, and you might cancel them while they're happening. I haven't added this yet, but there are plenty of places where I would want like a thread pool thing where you just push a bunch of jobs onto a queue, and then you set off the thread pool on them and wait for them all to complete. So that would be a separate thread group. You can see right now I have background threads, and what would happen is someday I'll add I don't know what you would call it, but like inline pool threads or something. So that's a group of threads for doing things all within the time of the frame. Kind of the way the rendering happens in Handmade Hero. But that doesn't need to be there right now because I haven't really set that up entirely. It would be a small addition. But anyway, that's the kind of stuff, and that would be for, you know, similar things like rendering or copying large amounts of data quickly if you needed to optimize that for something, and blah 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 blah. Right? Okay. So, grow thread memory. Now that is definitely something that happens during the life, like during a job. You're in a job and you say, you know what, the memory that this thread has access to is too small, and you ask it to grow. And I don't love that system. So I'm going to take a look at that and see if there's what? That's crazy. It's got to be getting used. Hold on. Grow thread. Oh, I've commented it out. I wonder why that happened. System grow memory. System memory. Okay, what's the system grow memory function? Well, really, where does all of this come from? System get memory. System grow memory. So this is just doing one allocation right off the bat. Do I do a free memory later? Yes. So this is just saying don't associate a fixed chunk of memory with the thread. Allocate and free as is a responsibility of the job itself. It's simpler. Like, it relies on already existing things. I don't see why I shouldn't just go with that. Unless anyone has a particularly good reason. I think the reason I would have done this is so that those get marked up in the system thread thing anyway. I think I like that better. I'm gonna go with that. Having like another interface for how to deal with memory that is for thread specifically doesn't really make sense. So that's good. Now, where does general memory come into this? So this, yeah, it gets some memory and goes. Yes, today was the first day I ever tried coffee, and it probably wasn't particularly good coffee. It was Tim Hortons. I'm guessing that's not good coffee. But I don't really know what is, and I figured I have to just start trying places. So we're gonna say that we actually don't need grow thread memory, which is again nice. What are you doing? There we go. Yeah, Abner, I'm exactly 11 months away now from being able to join your chocolate wine club. Actually, not exactly 11 months minus 2 days, right? So there you go. You can all work that out now. And I'm counting days as like a Roman when I look at my calendar. All right. Well, what else can we get rid of? Acquire lock and release lock. Almost definitely can't get rid of those. And the idea there is you have some IDs that you specify up here, right? These are the IDs of some locks, and you want the code to be able to choose when to lock them and stuff. And I've never loved this, but I'm not sure what I would do to get rid of it. And the thing is, you can't turn that into a data protocol very easily because locking is like about timing. You can't just say, hey, I want to lock this section of code, and then, put that in data, and then at the end of the frame, the lock, like, that doesn't make sense. That has to happen when you want it to happen. So the way to eliminate that would be to say anywhere I use a lock, find a way to do it lock-free. So I'm going to skip that for now. Okay. Debug message thread state. So this right here is an interesting function, which gets the thread states, and I use that for internal stuff, and that's a pretty good one. Like, I like this one because it just gives you all of the data about threads, which is just an array of data, really. And then you can index into it to find out information about specific threads. So I think running, pending. Yeah, I think I'll leave that the way it is. Same thing with that. Those will be fine. Those are actually unrelated. That's like debug. This right here is all Here's a question. Do I use thread memory anywhere? I believe I've eliminated that. So this actually, the job callback, it takes thread memory for one thing. We have an array of thread memories. I mean, it's doing a lot of work here to create thread memories, and like we saw, I don't think it's actually using thread memories anymore. So I think I actually want to eliminate this. Okay. So I want to see if we can eliminate this stuff, and if that thread stuff still works after the elimination of it. So I'll throw this in there, and we'll say, in lieu of having thread memory, what we'll do is we'll just say, there's a job callback, void name, system functions, the system, the context itself, the no memory, and there you go. Okay, so that cleaned up the only error in the application side, but now there's still all these guys here who are like, what are you doing? Defining all this stuff, it doesn't make any sense. And in case I want to put it back in, I'm going to delete it sort of this way. That way it's possible to add back in if I decide I want to keep it. But let's see, if I don't use this, alright, thread memory, I don't use this, thread memory size, that's like all about thread memory actually, so actually even this thing about memory request, we would have to like remove memory request itself to completely eliminate this. So if I decide that it's working, we'll say remove memory request. Okay, so down here we don't need to pass the thread memory. We don't need this function anymore. We don't need any of this. We don't need any of this. Okay, let's see if the program still works. Yeah. Let's see about large. Okay, that took an unusually long time. Might be because I'm in debug. I have another reason why I might have done that, actually. Yep. It's starting to make sense, because that didn't do in parallel, was the more unusual thing. But let's take a look at post job. I think at one point I might have changed post job to not actually, like, work intentionally, so... Or, oh, you know, okay. Okay, it's unrelated, but at one point what I said was that there would be no... Yeah, so there's the job callback. That actually probably makes a huge difference in terms of whether or not I get some of these errors. Let's see now. Yeah, I don't totally understand what went wrong there. I mean, what is this? Initialization of a function. Job full X. I mean, what's wrong with that? Any ideas on why? From initializer list to job callback, there is no. What are you talking about? Job callback. Oh, that's okay. Now, is this where we're doing? Yeah, this does the grow thread memory. Okay. Okay. Memory, undeclared identifier, memory. Okay, well that mystery is a little bit solved, so let's roll back some of these changes now that I'm seeing. We got that. Grow. The actual, like, grow thread memory thing, I must have deleted that stuff. Post job, cancel job. Grow thread memory. Grow thread memory. Alright, I'm going to try to put this stuff back in because it looks like there's actually is stuff dependent on it when I actually take out some test stuff that I apparently left in a long time ago. Okay. Grow thread memory. Sig. Name. Void name. I'm not totally sure what the arguments are supposed to be, so I'm going to go take a look at that. Memory. So it's just a pointer to the memory, actually, which makes some sense. And after I actually get this back in and working, I'll take a look and see if I want it this way. Because I was at one point a little bit excited to not have it this way, when I thought that this was a change that I could make, but yeah, I'll have to think about it again. Okay, so that puts the parallel stuff back in there. That puts parallel stuff back in there. And then it's just about this job callback situation. We need thread memory, and then I need to do use thread memory 0. Needs to be at 1. Alright. Ah, okay. So I think we better look into this. It's all old. Let's just run it. Well, we could probably get the same error on basic, hopefully. Alright, so where are we? This is during a thread, which is good. Why can't we see the code? App. That should be in file view. There it is. Okay. CPP took memory data. And the problem here is that we got something wrong in there. Oh, so the growth thread memory, right, okay, that's pretty straightforward actually. Growth thread memory, it exists, but it's not being placed system code. Yes, right here. We need to go back to putting this in. Grow thread memory equals system grow thread memory. Okay. You can see this right here is the thing I actually want to start paring down. I didn't actually mention it yet, but you've probably seen it a few times. These are all the functions that the system is providing, and it just seems like a lot. I want that to be smaller. Okay. Gotta deal with that tab bug soon, too. Alright. Anyway. That all appears to be back to working. Now, I mentioned that force redraw is actually kind of a threading function, and I'll explain why now. The idea of force redraw is that once in a while, basically the whole system only does a rendering phase when it knows the screen will be different than before, because this isn't like a game where like you just always assume you're going to re-render the screen every frame. A large number of frames don't need to be rendered, right? And it's not even really a frame. That's not the right, like, in the absolute best way to write an editor type thing, what you would want to do is every time there's an event, you process it and then you render afterwards if there's a change, but then you know, it has some problems there. You still have to like frame rate limit that, because if you hit two keys, you don't want to render twice within a few milliseconds. That'll be like weird. And you know, it seems to me, I just know games better, and it seems to me like the easier thing to do is to set it up with kind of a frame system, but it still only renders when it thinks there's going to be changes. And once in a while, the thing that causes there to be a change to the screen happens in parallel to the main thread. So I have this thing here that writes to the, basically writes one bit that says, hey, next time you check to see if you're redrawing, you want to do this. But for some reason I decided that needed to be like thread safe, and I'm not sure that was the right like way to think about it. It's actually not this hard of a problem. The point is just to have some sort of shared spot that anyone can write to, and then at the beginning of each call to the system, like each time you call the application main step function, it needs to get the result. And if it's off by one frame, you don't really, that isn't a huge problem. And more importantly, it could be set up in such a way that it isn't actually a system function that allows you to do this. One second, I saw a question here. Fucon, I don't think I fixed your bug. I think when you asked about the bug, when you asked me about that bug, I was at a point where I couldn't deal with it, and it's like on my to-do list. I know there's a few like finicky bugs with empty files and stuff like that, and empty lines and stuff like that cause weird problems. And I'm at like a point right now where there's enough stuff that's in flux that I can't debug that, because if I debug it now, I could end up just throwing away that anyway. Like I could debug that, but the changes I make would solidify me in a certain direction, which isn't even the direction I'm actually trying to go right now. So it's like I'm at a state where once I get to the next like sort of region of the program's possible state that it makes sense to sort of do detail-oriented stuff, I could debug that. But right now I'm trying to sort of push through to the state where I've got this nice like well-defined layer that I'm happy with for porting, so I'm kind of ignoring those issues. I can only do one thing at a time, but I'll definitely get to fixing that as soon as the port stuff is ready to go, to answer your question. Those kinds of things will get the attention they need at that point. Okay, so now there's a few things to think about. There's this force redraw, how I might fix that, and the thing there is, how do I make sure that every thread gets a pointer to some some like memory for exchanging info to each other that's the same for all of them. And the way I'm doing that right now is that it's just in the platform layer, there's a struct, right? So it's like in the data segment, and that's how everyone gets it. But I think maybe that's not what I want, because that means it has to be on, like, split across the barrier, right? If this is the barrier, and on this side I have system, and on this side I have the application, then if my exchange memory is only accessible to the system, then I have to basically do getters and setters for all of my exchange memory. Even though it's just memory, what I could actually do is just have the memory be allocated here, but pass the pointers over here, so that whenever this wants to do something, it's already got the pointers to it, and they don't need to call through the barrier, right? The barrier passed access this direction, right? So this guy will actually pass access, direct access here through a pointer, and then these guys don't need to call back, right? And as much as I can avoid calling from the application back is kind of what I'm trying to reduce. I'm trying to reduce calling back into the system. So I'm going to set that up, I think. Because there's a few other places where I might get to use something like that too. Win32 vars, right? And what I have right now is this sort of set of variables that are sort of private, if you will, to the platform layer. And what I really want to do is set up a separate set of like this could actually, you know what, be, this is, yeah, so this will go in system reusable because it's going to be the same on every platform. Thread exchange. So every, the main thread and all of the background threads will get pointers to this, and maybe even the thread pool when I have that. And they'll use it for exchange. So for that purpose, I want like a force redraw, kind of like I have up there. And let's see, we could have just threads exchange, something like this. It doesn't even really need to be global because I'm gonna try to pass pointers to it everywhere. I was like slightly verbose names. I think this should be enough. Now, I was saying I don't really think I need to be thread safe. And I bet the reason that was U32 was for the exchange, the purpose of being able to do that interlocked exchange. But, exchange dot force redraw, and then afterwards set that to 0. Now, okay, so that's where there might be a bug, right? Because you could say read from this and it sees a 0, then some other thread, like right then it stops, some other thread goes and sets that to 1, and then this sets to 0. It's unlikely, but that's a problem. So actually, I have to take it back. I do need interlocked exchange. What? Why is there a button in Emacs for minimize? I want to turn that off every time it happens. Okay. Interlocked exchange. Except now it's just the exchange's force redraw. I think that means this does need to be volatile, probably. Now, if it has to be exchanged, that means it has to be exchanged when I write to it as well, right? And that's kind of iffy, because I'm wondering, how do I do that? Do I provide an interlocked exchange function instead of a sys? I think I better provide interlocked exchange, is what I'm thinking. So, do I want to really pass that as a function through a pointer that calls and does an interlocked exchange? I mean, that can't be inlined at that point. See, this is probably why I chose to do it in the first place. But, you know, with the particular function for setting the particular guy. But I mean, it's actually not any better. It still just does an interlocked exchange under a function. You know, in practice, it's not better. Like, not in practice, like in reality, it's the same exact thing. With less flexibility. Yeah, you'd think I could macro it. The problem with that is, well, I don't know. Interlocked exchange is platform dependent, and the application code, like, literally has no platform dependent things in it. Right? When I build that DLL, okay. So the point is, on the other side, it's got to have the ability to write something. And we don't really care if that write happens before or after this exchange. We just need to make sure that... I don't want to, like, introduce locks for that. Well, I think for now the right thing to do is to provide interlocked exchange as a system function. Just because it's the same, I mean, it ends up with the same number of functions, so I haven't even achieved what I wanted. But, I don't know. It's at least better than this. Do I have to tell it that's a volatile? I don't know. I don't know how that detail works. Right, so I provide this as sort of a primitive you might want, and the system will provide it however it needs to. Yeah, that seems fine. And then you can be sure you never miss one of these force redraw messages being written. It just seems like I'm providing too low a level of set of features, like messing with the locks yourself, doing the exchanges yourself, but like it doesn't actually reduce the amount of stuff there is either way. Wait, what if each of them have they can already do it? If it's a one, then you clear it. If it's a one. Okay, I've got a plan. Alright, alright. Silly me. This should be actually doable. So we're going to say there's no such thing as that, but I'm ignoring the fact that it exists. Interlocked exchange also won't exist. Yeah, okay. Okay. Exchange. Okay, so the real trick will be to say there's a way to do this without an exchange at all. I look at the current value and I say if that is a 1, then set this to 0. Now the nice thing should be the handmade hero code base just has a conditional compile in the handmade platform.h. Fire Jake, what do you mean by that? The handmade hero code base just has a conditional compile in the handmade platform.h. In reference to what? Like, what problem are you referring to that the handmade hero base code base solves that way? Anyway, I was thinking this should actually be fine if I do this way, because now if the redraw is like captured here, that means that there's no, like, there can't be a syncing problem now, because either before this there was a 0 there or a 1, like, and if there's a 0 there, if there's a 1 there, then if in between here and there another 1 posts, it doesn't matter because we already captured a 1, right? And if that was 0, and then we store 0 so we don't do a redraw, and then somebody switches to 1, this value doesn't matter because we're not going to switch it back to 0, right? So this doesn't actually need to exchange, like, interlocked at all. Yeah, Fiery Drake, that's fine. I mean, that is still platform dependent, right? Like, I mean, it might not be. Yeah, it might be misunderstanding. It might be like architecture dependent, because I don't really know. In which case, it would be less of a problem to put it on the. But that looks like it's like platform code, and mine's a little bit different from Handmade Hero in a few ways. So, mainly because I want to get the DLL thing to be possible for people. Fucon asks, decided on a data structure yet? I'm assuming you mean for the buffer experiment, and the answer, I'm leaning towards gap buffer pretty heavily. To be fair though, I haven't done like my second round of optimizations, right? I got everybody within the same range, plus or minus one, one standard deviation ish. But the thing is, like, I haven't taken the time to see how good could it get. But there's an argument to be made that the thing which works out best under like the least optimization work is the best option actually, because if I have to do a ton of work to optimize something, that's going to make it harder to maintain and use and stuff. So maybe the rope or the multi-gap buffer is actually better than the gap buffer under a ton of optimization, but for maintainability the gap buffer is better because of how good it is even without optimization, right? So that's why I'm leaning pretty heavily on gap buffer, but for the completeness I do want to do a second round and see for sure, but I'm pretty sure it's going to be gap buffer when I'm done. Like plain old vanilla gap buffer, not the fancy one with the multi-gaps. Okay, so now all I have to do is this right here. This function basically only exists so that threads other than the main thread can report that they want to do a redraw. And then that gets passed to the main thread so that it does the redraw through that other system. So really what this needs to be is it needs to have access to the exchange struct. And that means if I go to the system.h, that the job callback, and this can, we're settling on this for now, so I'll just put that back to that way. So this is taking system functions pointer, the thread context pointer, thread memory pointer. I want to add a thread exchange pointer. Okay. So that's good. Okay, so that's fine. And now instead of force redraw, it's just exchange force redraw equals 1. True. Okay, so I guess I just define that here actually, because this is actually also reused between two platforms. There might be an argument to be made to say that I just don't need this file. This was actually silly because this file on the left here is the one that's actually the reusable system stuff, right? It's declarations that get used, and this right here, the only reason I wouldn't maybe put that there is because it's not technically a interface to the program, but I don't think that matters so much. Because I'm the one writing the program right now anyway, so I don't need to separate things which are and aren't visible to the program. So I'm going to do that way, and we're going to kill this file. So that's nice. Okay, and then we just need to make sure to pass in the exchange pointer here. Now the question is, how does the exchange pointer get here? Well, we get a thread context. We have a queue. I could easily pass it through the thread context. I could also make it a static global variable in the application. I think I'll do that. That's the least work. So there it is. Exchange equals, oh, there it is. Okay, so it's exchange vars. I'm just going to pull this up to where I declare this. Exchange vars, exchange, comma, throw in the vars there, and that's obviously a pretty long line at this point, so break it up. Let's run it this way. Cool. Alright, so we actually were able to eliminate that function, I think. Or at least we should be able to now. I don't know if we've actually gone through and gotten rid of it entirely. Maybe we have. Okay, so force redraw is no longer a function. Okay, right here is all of the thread stuff. Okay, so now all that's remaining, systems, that's debug. Let's see, the post a job, cancel a job, grow thread memory, acquire a lock, release a lock, force the redraw. Wait, force redraw is still in there. I thought we removed that. Okay. So, the rest of this is a little bit hard to see how I might reduce it. I mean, it's 6 functions. Post job, cancel job. Like, the thing is, cancel job has to happen right away, because the time when you cancel a job is when you're like, hey, I know you're reading from this memory or something, but I'm about to invalidate that, so stop, please. And let's see, grow thread memory, because we're associating special memory with a thread that's like its own space for that particular thread to use, and I'm not sure why that's better than just having that. I mean, it's just simpler, I think, is the reason I do it that way. It's like I don't have, like, the person who has to write that, it is simpler. It's more complicated for the person writing the platform code. If the person writing the platform code didn't have to deal with that, it would be a whole function you could just get rid of. So there's a trade-off. Simpler on the platform side, simpler on the application side. You gotta write multiple platforms. But you know, the application side is going to use that as an API multiple times. I think that the benefit on the application side is pretty small, actually, because it's pretty clear to me that the only benefit you get out of not having to do the thread manually is, like, you only have one system call instead of a few, but they're all system calls you are used to using anyway. The other nice thing is the grow thread memory sort of, it means you only have, like, you always have them. You don't have to do an alloc at the beginning of a function and then free it, just to do an alloc at the beginning of the next thread and free it again at the end. And it also, it doesn't get interlocked with other system allocations, which is true, right? Because I know that, like, that's a good reason to want it. So many pros and cons, you know? Hmm. Alright, so what I want to look at is job is pending, because that might be the only one we can really do something about. What does job is pending do? You put in a group ID and a job thread group ID, a job ID. So I'm guessing that that is just sort of looking something up in an array. Is pending. Actually, here it is right here. This might be one of those functions that I never got around to putting in the new system. Is, yeah, okay, so is pending. Okay. Alright, so that simplifies that down to one function. When I say cleaning up, what I mean is I had an old system where I just had uh, like declared the functions, and now I'm passing them through as pointers. And when I was doing that, I sort of tuned what I wanted the pointers to actually be in terms of their types and their names. And some of those things ended up just having two layers of call stack, right? So I've already done the thing where I fixed sort of names and pointer types to be what I want, but some of the functions I just implemented by taking the old function and calling to them with from the body of the new function, which means the call stack was a layer deeper than it really needed to be. So what I've just done now is reduce the call stack. So now that sort of is what I meant by cleaning up. There's not one function where there used to be two. Um, because now what I'm trying to do is reduce the number of functions that are kind of going on here. So it was the proper time to do that kind of cleanup. Okay, so and I have I probably have a pretty bad habit of just leaving things in that sort of messy state for a very long time. Like, even though, Abner is, of course, the person who says, don't worry about your cleanliness too much. I sometimes wonder if I don't go way overboard on that. Like, I just leave it in a mess for so long that it starts to cause me problems. If I had just cleaned it up a little bit sooner, it would have been there. And when I mean clean it up, I just mean kind of, using Mike Acton's terms, like adding less of my mental model, adding less extra stuff to the solution, right? Um, so not cleanliness in any terms other than what's the simple way to solve this problem. But I often have a little bit of extra stuff just from the organic process that led to the code in the first place. And so I had extra stuff laying around that I just didn't clean up until just now. Anyway, so let's see, job index, yeah, okay, so what I can do is, that looks like there's no name conflicts, so I just grab all that. And now I'm grabbing the queue from there with the group ID. Yeah, not a single one of those things actually uses like a lock or an exchange, which makes me hopeful that what I could do is just sort of say that the queues themselves are actually accessible, right? If I just say you can access the memory of the queues whenever you want, that could be a function that is like compiled into the both sides rather than passed as a pointer. Oh, 1 second. There we go. When does Handmade Hero start? It's not for a couple hours, right? So I don't want to go too close to that. Probably another half hour or an hour or so. Okay. So basically, the point of job is pending is. Okay, let's see where I use that. System.h job is pending. Where all does that get used? No way. It's like an unused function. Okay, so what I'm going to do is say I do want to introduce I don't know, like forward thread CPP. Right? And then oh wow. I'm almost to a full year of development. You can see right there that I'm almost to a full year. Because this would have been the very first day, because that's when I made the platform layer. So system job is pending. Yes, I believe that what I want to do is just say we have a function that takes a work queue and a job ID and does this work here. And then there's actually no job is pending pointer, so that's nice. Fucon, no, I have no idea how you would end up getting the custom DLL loader to like interact with the debugger on Visual Studio. I wish I had remembered that because there was a lot of talk about debuggers. Like I had sort of, I don't know. I always think of a bunch of really great questions like right after the appropriate time to ask them. I don't know why it is. Uh, I think the pressure of actually having a conversation causes me to lose focus. But there were a few people discussing debuggers at several occasions over the weekend, and I really could have asked, like, does anyone know how you set up debug symbols this way or whatever? But I didn't, and I still have no idea how I would do that. And there's not really anyone out there who makes sort of information. Like, I can't even figure out if like a module is something you can create, but it really seems like that's not true. And based on what I can gather, I think the only way to do that would be to make my own debugger or to use a different debugger. Hello, James. Alright, so let's see. job is pending can go over there in that layer, and like I'm just saving that. I'm not including that anywhere for now, but if I end up wanting that, I have the ability to do that. And the other thing is, should I expose these queues? And I think the answer is yes. Right, so up here we have win32 vars. Before I wasn't exposing them because they're not they were not like they were, I considered them platform dependent, but I've decided a work queue and a job and that kind of stuff is actually independent of the platform, the way it's defined. So that means we can do a little bit of stuff to sort of, the more you can have in the independent side, the better, because it's less work to do a port, right? So I'm just going to see if I can move every part of that into the independent part. Right, thread groups are still platform dependent because of what? Thread context pointer and account. And a thread context contains what? And a handle. You know, even the thread context could be platform independent now, I think. Well, what's this Windows ID? I think it's a little bit of a hard call because there's a little bit here that I'd have to change. I can replace that with a platform independent handle type, but what's this all about? I'll wait a little bit longer to decide on whether or not those can go, but I think the work queue can almost certainly become platform independent now. I'm not sure about the locks. That seems pretty unlikely. But the work queue is literally just data at this point, so I think I want to figure out how to put that in the independent section. So application system functions, render target, application memory, key codes, clipboard contents, config, API. Right. Why is there a thread context? Yeah, that's old. So application memory. Where is that being defined? Okay, that's right up there at the top. That's just pointers to the two memory chunks. So basically what I have going on here is like, here's the system functions. Those are separated because they get passed around all over the places. Pointers, render target is a pretty good separation. Do I want to add a new thing that's like, well, I should be passing exchange variables in here anyway. Maybe the work queue should be considered part of the exchange and that gets passed in right here. So thread exchange. Okay, and this will become a part of the thread exchange. That's like I think that's in system. The exchange, yes, okay. So now we have a work queue right here, and those, we'll just put them in the threaded part as well, I guess. Yeah. Job data. Okay. That's interesting. So it looks like we have a little bit of a dependency loop there, but that's fine. Drop that down here. Wish we were using JAI where this stuff isn't a problem. But alas, we have to wait for the witness first. Yeah, so that's just in exchange vars now. See, code transform would have solved this. I would just say, hey, this exact member, treat it as if it's in this global variable instead of this global variable. Done. Because a lot of times structs are used to group global variables in specific ways so they can be turned into pointers to things. Oh. Or so that they can be cleared to 0 together is a really common reason for me to put stuff in a struct, is just to say all of these clear to 0 at the same time, right? Like if you put all of your variables together and say define them to, they start at 0. People always say like, oh, an annoying thing is like you gotta make sure all your global variables get reset when you start a game. And I'm like, what are you talking about? If you just group them in a struct and clear to 0 at the beginning of the game and clear to 0 when you want to reset. That's like the whole thing. That's all there is to that. Okay, exchange vars. Alright, app init. What is this thing doing? Oh, that doesn't go there. That goes in step. Here we go. System, key codes, input data, mouse state, render target, application memory, thread exchange. App step. There we go. 132 and 32 memory. Exchange vars. Exchange vars. Now the interesting thing is I've got, this is actually like not even, that should just be like memory vars at this point. Because that's the same on every platform. Okay, that's a slightly unfortunate name. I see that now. What the hell? Code transform, please. Nope. Gonna show you errors instead. Memory vars. All of this is stupid. Okay. So, nice. All right, so we've just moved all of the queues, the queues into the exchange stuff, which is pretty cool because that means it's exposed now. And if I ever want to, I can include this into the application and just do job is pending whenever I want. Of course, we've recently realized that I never used that before, but the code is still there, and I tested that at one point, so it might still be correct. Who knows? In the meantime, we can talk about in the meantime, we can talk about what I want to do next. Let's take a look back at the system header. Job is pending can go. Okay, so now the threading is down to 5 functions. So we've done a pretty good job. I think it started off with 9 functions. We're getting to the point where it's pretty hard to imagine a better set of, like, a smaller set of functions. These are still, like, it would involve lock-free code. What I'd like to see is where are the places that I would have to rewrite code to be lock-free in some way. So there's all this stuff with the frame lock, frame lock again, frame lock again. So the first frame lock happens so that we can do the initial allocation, and the other ones are for growing. Right, that's so that we don't... Okay, I remember what those are for. Acquire lock, release lock. So really, the only time I'm using that is for the frame lock. I have a bunch of other locks that I set up at one point, but really, the reason I have the acquire and release lock now is for the frame lock. So maybe that's really all I need it for. And the frame lock was an issue that I wrestled with for a while. So let's look into this and see if I still agree with the decisions I made back then, and if I do, how I want to condense this code to have less functions, hopefully, in the system layer again. So, the whole point of the frame lock is that it gets, whenever frame lock, well, let's see if, because it looks like this one might be using locks for other reasons. Acquire lock. Ah, so that's where the locks, that lock uses all system side. The only lock that we've actually exposed ever, like that we've exposed them all, but the only one we've actually used is the frame lock. And I think it would actually cause bugs if we tried to use the other locks in the application side. But it's not really a problem. I could just leave these locks in place, right? I could just say these locks always exist. They're just not exposed, right? And so then, yeah, not a problem. But let's take a look at this. We acquire a frame lock there. And then what happens is we release it whenever we want to do the waiting, and then we acquire it again. And the idea here is anything that needs to be done anything that needs to be done that's like, oh, it's got to like use the general memory system, so it's a general purpose allocator, and I don't want to have two things using it at the same time, etc., etc. I could individually lock each of those systems, or I could just say, if you're going to use one of those systems, wait for the end of the current frame, because then we're going to release the frame lock. You get your frame lock and you do your sensitive operation, then you can release that again, and we'll be sleeping at that time anyway, so it's like perfect time for you to like do some work, right? So other guys who are trying to do stuff that's like sensitive to thread race conditions and stuff, they just come in and do that work while the main thread is sleeping, and then eventually we get done and we lock again, so anyone who wanted to finish like just finishes, and then we get back on. So that right there can cause like slight moments of like the frame rate going worse than it was supposed to, because we already waited as long as we wanted, and if we have to wait for someone to do some work, then it goes past the 30 frames per second. We don't really care about hitting the frames though, because it's not a game, it's an editor. And there's also the factor that even though still it could be a problem, like what if I'm copying 10 megabytes of data, that can cause unwanted like skips. So to limit that, like I said, I don't ever do too much work in one like locked section. But I don't love any of that. Like that means the person who writes, the person, when I say the person, that's me, but also people who write plugins later, if they're going to do stuff that works in parallel, that has to do something like why is this, by the way, the destination, the source, the copy amount? That seems a little peculiar. Like, I'm not convinced that that's a good idea. Canucles, mod rights, denied. I think Miblo's kind of the only mod I need, so you know what? I'm not gonna cheat on one mod with another. You know what I mean? Like, it's just the way things are. Anyway, do I actually need this frame lock here? What was I thinking? The only thing I'm locking is copying data into the destination. So, why would that need to be frame locked? Like, it's partial data either way. What was I thinking? I mean, I guess I'm thinking, like, I don't want a situation where somebody's looking at the tokens and trying to read from them, and then they get changed, but that shouldn't be allowed. Like, they shouldn't be reading from tokens anyway, right? Like, am I crazy, or what's the deal there? Well, okay, so they could be reading from the tokens because they at least render, but that seems broken anyway. Like, they shouldn't be allowed to use partial tokens. On the other hand, it doesn't. How does this work? I feel like I either did something very clever or very stupid here, and I can't remember now. And this is why I don't love the frame lock, because it's eh. um, why would that work? It seems like it shouldn't work because if it's gonna read from these tokens, which it has to do the rendering, if it reads from the tokens to get the coloring and it's like halfway through the tokens, there's a spot where they're out of order or something, that's no good anyway. So what is the rendering actually doing? I guess is what I need to know, because I'm still not, I don't buy it. There's something going on here that doesn't make sense. Yes. So let's say I'm trying to draw a file view, and I'm coming along and I say tokens complete. Okay, use token. Tokens use. When do I use tokens? Tokens use happens when I have the file. The tokens are complete, and the count is greater than 0. Are the tokens complete? Status. Tokens complete. Let's see if we can find mentions of tokens complete. Okay, first of all, that's confusing. I don't need this anymore, so, you know, bye. Everything's parallel again. Killing the tokens clears them out. For selects parallel, you set it to 0. tokens exist. Okay. I mean, ideally what would happen is whenever you're doing a parallel lex, if you had old tokens, you'd keep them around and you'd read from them while you do the rendering and stuff. Like you'd treat them like they were right, and then you would all at like in one frame at one moment you would just say swap in the new ones and discard your old ones. And probably the reason I don't do that is because I don't like I at one point didn't like the idea of having two sets of tokens allocated at once, which is kind of a dumb reason. Like, I don't know. I mean, is that really going to be an issue? I don't think so. And if it was, you could even have a rule where it's like if it's not going to fit to double up the memory, you have a special path you go down to handle it. Hard to say, hard to say. I gotta get these hyperlinks working at some point soon. Side thought. Tokens use. The thing I don't get right now is he says tokens complete to 0 when he does a lex parallel, and that means that tokens use. If you look at this over here, that kind of suggests that you don't use tokens while you're doing a parallel lex. But that doesn't seem right. Like, it doesn't stop using them and start using them again. I just need to like run the test and actually see, because that's like kind of weird. Okay, that's weird, but I'm ignoring it for now. There it is. Lots of tab bugs on display there. But anyway, the more important thing is, say I insert a character. Okay, what about you can see it's taking a while to reparse, but it did that in parallel, and in the meantime it was still using tokens, right? So what gives? I don't understand how that's possible. It doesn't make sense, because the code certainly doesn't say that that's what should happen. So what I want to do is say file view. Let me close this right now because it makes things run slow. I want to find draw file view. Yep. Okay. Right here's where I want my breakpoint, but I want to turn that off for now. Deep in file. Okay. Um, and then what I want to do is, I'll go boom, boom. It'll put those in. Now when I delete this, I'm going to put this on the other screen so that I can have these windows not overlap each other. But I'm going to delete that character, right, that star there, and turn it into a non-block comment. And we saw how long it takes it to work that out when it's in debug, so it's going to work on that. And while it's working on that, I'm going to put the breakpoint in, and we're going to figure out why it's using tokens. Okay. So what's going on here? We got a file, tokens complete. It says tokens complete is 1. Okay, well that answers why it thinks it can use tokens, but how did that happen? Because I'm pretty sure the code doesn't say that should happen. I could be misunderstanding. Relax parallel. First lex parallel. Relax parallel. Okay, so down here it's launching a job. And it looks like what happens is if I'm doing a first lex, I set tokens complete to 0, but if I'm doing a relex, I don't. So a relex means we're keeping the old tokens and we're just plopping in this new stuff. And that's where, if that's true, then that's kind of confusing, because it's like, does that actually work? It doesn't seem like it should. Like, it shouldn't be able to read from tokens that are, when the array is half modified, which is what the code I wrote says it does. So it seems like that needs to change. Seems like that needs to change. Trying to decide whether I want to work on that now or keep pressing on this lock issue, because I guess, yeah, I can't really know how I want to use the locks until I consider fixing that. So that seems like bogus. I'm going to work on that. Yeah, so what's happening here is we're copying into this destination, but really it's like we want the file to have a swap stack, right? And then we're actually copying into the swap stack, and then it's right at the end, once everything is done, you actually perform the swap, right? And that could just be a matter of saying at the beginning of every step, you loop through the files that are open, that have pending jobs even. You could like pare down to just those. And if you see that one of them has finished their job, you do the swap there, or you can just do the swap here if you want. I'll probably do the swap here for now because it's easier, but it costs another frame lock. And then I wouldn't need to do these locks here actually. Like I could just do the copy all at once, because the swap stack is like free to use, right? So yeah. Alright. I think I've approached this enough times and I've come to the conclusion that whatever I was doing in the past was stupid. Okay. Now up here, token stack. This should be the swap stack. We're gonna say that actually, I don't think there's any good reason for the swap stack to have a realloc case, right? In fact, I would like to assert that this is 0. Instead of doing this if, we'll just assert that, and we'll do this case. So there's the swap stack. Now that really raises the interesting issue that what if the job gets canceled? I guess anytime you cancel the job, it's also your duty to make sure you free the swap stack. Because the alternative that I'm thinking about right now is what if I just say sometimes you have memory sitting around that like you didn't want, but that seems like a total mess. I don't want to just have allocated blocks sitting around because something got canceled and they'll just, once they're needed, they'll get reused or possibly discarded anyway. Like, yeah. So I'm gonna just say the swap stack goes, gets asserted to 0. NORAD91, welcome. Now, I'm not adding multi-threading, I'm just sort of cleaning up the multi-threading. I'm actually working on a port, but right now this isn't the port. I'm like cleaning up the platform layer so that to make my porting work easier. But we are looking at the multi-threading part of the platform layer and trying to figure out what we want to do. And actually what we've just stumbled into is a part of the application code that I think is broken and that I want to fix up a little bit. That it has to do with multi-threading. So, we're going to allocate memory for the swap stack. And then that's just going to fill in the swap stack. No need to frame lock any of it. In fact, no need to do this loop at all. All of that's no longer needed. None of this is needed anymore. Instead, we'll just mem copy into the dest from the source using and by the time we've done right, where's the frame lock get acquired? It gets acquired right there. That's when we do this one allocation. Okay, great. Okay, that does a mem copy, and then what we say finally is at the very end, like, whoa, is that correct? Is something fucky? There's the problem. Whoops, I didn't want that. Oh well, gave it to me anyway. Instead, we'll just have one frame lock here at the end for doing these, because these should probably be frame locked anyway. And what I'd really like to do is, like, I love whenever I've got like an open close in my code or a lock unlock, whatever. I love to put extra brackets around so it does the indent So anyway, token stack, and then what we really want to do is general memory free, general free the tokens there, and then now, like I said, this isn't totally correct because if the job gets canceled, we have to set swap stack tokens to 0 and free the memory that was there. Which, like, that's actually the main reason why I like thread memory now that I think about it. The whole idea that a job can be canceled is a huge pain in the ass because it can get canceled anywhere in there. And that means no code is ever guaranteed that the next thing is going to happen, right? You can never guarantee that once this is executed, the next thing will also execute. And that's, like, really bad, actually. What I should do is actually maybe fix that. Like, now that I think about how much it affects what I do, and the way I could fix it that just occurred to me is whenever I'm about to cancel something, it's because I want to do a certain operation, like it's reading from some memory, and I'm about to free or change that memory. I don't want there to be a conflict. What I'd really like to be able to do is just say, it really doesn't matter what I do. I still need the ability to say pause this execution. It's very tough. Doesn't actually solve the main problem. I was thinking I could make canceling, like I could in a way make canceling only happen at the end of frames, so like the threads keep going until the end of the frame when it's like, okay, if you've been marked for cancellation, do your cancellation now. But what good does that do? Okay, so anyway, the swap tokens go in there. You clear that to 0, release the frame lock. And the only thing is, during a frame lock, you're guaranteed not to be canceled. So like that will definitely all happen if it starts happening. Because a frame lock, things can't be canceled during a frame lock, and jobs can't cancel other jobs and stuff. Okay. Now that just means whenever I do a cancel job, then I have to free the swap stack and clear it to 0. Alright, Fiery Drake has some information about multithreading, so I'm going to engage in conversation with Fiery Drake at this time. So you're saying if you can stomach waiting, then you can do a cooperative pause that doesn't need to be end of frame. Yeah, okay, so my question is, how does that matter? What does a cooperative pause get me that's actually useful? Because my main problem is that if I do a pause, then that means things later in the code don't execute. And it seems like what does it take for a cooperative pause to fix that problem, right? Does it fix the fact that something later on won't get executed? Because mostly what I deal with is there's cleanup at the end of the function that needs to be done. And like there's some crazy stuff I've thought about doing where it's like cleanup gets thrown into an extra function that is like a callback that if you cancel, you call it, or if you complete successfully, you call it. But either way, you always call this callback. But that gets really nasty. Like, what if you haven't even gotten far enough for that? Like, it's a really nasty problem. Okay, so it's not just about when. Okay, the thing I don't care like I said the requesting thread, the thread that wants to cancel. Okay, so you're saying my thread has like the job thread has to be written in such a way that there are points where you say, hey, at this point check and see if we've been canceled, and if we have, then like do thing, right? But right, so like if we check and see if we've been canceled at certain points, and then only halt this thread if uh, well, what I didn't consider, like I didn't consider the idea of putting points in this thread. Well, I've considered it. I just rejected it, but it might have been a wrong rejection. What I don't like is I don't like having to do too much cooperative work like from this thread. I really wish it was easier to write this thing such that the person writing the thread didn't have to think much about the syncing. And obviously I failed because I've already got a lock and unlock in two different places here, right? But the idea is if I'm willing to like write this code in such a way that every time I touch multi-threaded code, I'm thinking about the fact that it's multi-threaded and like willing to do the extra work, right, to make it work that way. Then I can go in and go, oh, like let's see right here. It's like here's a cancellation point, and then it's like if cancellation point thread context, right? And that checks and sees if we've been canceled, and then it does some cleanup, and then it's like return, right? That's what that would look like, right? And then I could do that in a few places, like okay, to do it here, and then maybe I do it here. And I just pick good spots, is what you're saying. Maybe after each expensive operation, I do another one, and I don't have to put it in a few spots. But that's interesting. It's a hard thing. Like there's an advantage to be had for saying this thing only ever has to think about the fact that like it's its own self and doesn't have to cooperate. Like operating systems don't make you write cooperatively for the same reason. And if there's going to be plugins, I'd like it to make it easy for plugin writers too, right? So it's not just a matter of like me being lazy or ignoring a problem. It's like if a plugin writer has to cooperate and they don't, that causes problems. So it's more like the solution has to be non-cooperative if it's going to be a really good solution to this. The other thing is like maybe plugin writers just don't get to use background threads. So the other thing that I could do is, like I said, operating systems are non-cooperative, and the way they handle this particular problem is they have like they keep the set of handles that they need to free when the program closes. And what I could do is say that a thread doesn't just call general memory allocate like it does right here. What it actually does is it says, if you're going to do this, that's fine, you can do it, but there's a special function. You don't get a pointer to a general memory system. You get a pointer to like a threaded general memory system. And then when that happens, that means that there's like thread metadata that keeps track of because it keeps track of uh, uh, like handles to the memory that you've allocated, and then when it closes, you free it. So Garlando says, I had to tell Mibble about your game because you never talk about it. That's true. I never talk about it. But I have a game. I even, it's not that I'm embarrassed. I mean, or not proud of it. There's certain things about it that I'm proud of. I definitely look back on it and think like, oh, that I should have done like. I should have done it better, like in certain ways. Like I'm disappointed in the fact that there's some really cool stuff that I had that I wanted to show through the game. Uh, uh, and like there's important ways in which like I didn't understand how to make a game well enough where like I didn't get through, and I will need a really good excuse to actually be able to show it. Like the amount of stuff I learned about a checkerboard making that game was crazy, and I don't think most players, like a few of the people who played it, showed signs that they were getting it, but like I realized I didn't understand what I was doing well enough to actually get it through. But mostly what just happens is I forget about it. Like because no one played it and I only talked about it with a few people, and like no one asks about it ever. Like you're the first person who's ever brought it up on stream. I just forgot that it exists most of the time. Like, and the funny thing is, Jonathan Blow actually like bought the game at one point, which really excited me. I was like, oh, that's awesome. And like as soon as I came home, I was like, why didn't I like? I should have asked him about the game because I'd have loved to hear what he said, and I forgot. Like I just forgot that it even existed. For people who want to see the game, I'll go ahead and plug it because I guess that's the point, is that I don't talk about it enough. But the game's website is still up, and you can see like some videos of people playing it, and there's a demo here. And in a couple months, I'll probably make it free because I'm like, there's no sales or anything at this point. There were for a little while some sales, but there's not anymore, and it's like, what's the point? I'll just make it free. At the 1 year anniversary, me and my partner discussed, my partner who worked on the game with me, we discussed we'll make it free at the 1 year anniversary and just leave it at that. But yeah, this is the game. You can check it out. We don't really update the blog anymore, but that's where you can find it. Garlando, what I could do is I could, like, I don't want to get back in the code base. I did the object, like the OOP confessions, which is actually about that game, and I just don't want to code it anymore. But I could show you how to like compile an art pack and see if you can make a better one. Abner, I can't put it on handmade dev. I can't because it's not good. Okay, we could do it that way. We could say here's a target. Practice by rewriting this in a good way. It's really bad code. Like I really wouldn't want anyone to read it. Like it's not good. I wouldn't mind open sourcing it. Like the only reason I don't want to, the only reason have never wanted to open source it is because of how bad it is. Like you saw the video, and I even find some of the worst things in there. But we could put it up. We could do that. Alright, Handmade Hero is only an hour away, so I'm going to take a break because I need to eat. But thank you for joining, everybody, as I worked on this, and for the chats and things. I'll be, uh, I'll be around for Handmade Hero and everything else going on. So, see you around.